Hello, welcome. This video is going to correspond to sections 1.21 up to 1.24 of the textbook, at least the textbook as it is in September 2016. So the topic is establishing or determining an argument's form, translating from natural language into formal notation. And an argument we saw in the last video and previously in this chapter, an argument is going to be a set of statements, okay, premises and a conclusion. And so the main part of the form of an argument is going to be determining the form of the statements, the form of the premises and the form of the conclusion. Now, a statement's logical form then is, at least those we're going to talk about in this course, is kind of determined by two things. There's what we're going to call the atomic statements that are parts of those statements or parts of some of them, and the operators, if any, that combine those components into compound statements. And that's going to tell us what the form of those statements are. And then when we put those together in an argument, we get the form of the argument. So the first thing we need to get clear on is this distinction between atomic and compound statements. This is something that once you understand it, it's pretty easy, but the definitions look weird. But here's some definitions or some characterizations. So a statement overall, whether it's atomic or compound, a statement is something that makes a claim. Okay, typically you would express it with a declarative sentence, so not a question or an exclamation or an imperative. Well, we'll get back to that. Now, an atomic statement is a statement that does not have parts which are themselves statements. Okay, a compound statement is a statement that does have parts which are themselves statements. So let's look at some examples. So this is the rabbit argument, and this has the same form as the pizza argument, right? It's either x or y, not y, therefore x. So this is the argument. Now if we look at, and there's three statements involved, 1, 2, and 3. But if we look at some of these statements, we can see that they have parts which are themselves statements. So let's look at the first premise. That's a statement. The first premise is either the rabbit ran down the left trail or the rabbit ran down the right trail. That's a statement. It could be true, it could be false. Okay, but that's a statement. But notice it has parts which are themselves little statements inside the big statement, right? The rabbit ran down the left trail. That could be true or false. That's making a claim. Okay, the rabbit ran down the right trail. That by itself would also make a claim. Okay, so premise 1 is a compound statement because it has parts which are themselves statements. Let's look at premise 2. This also has a part which is a statement. The rabbit ran down the right trail. It's got this other thing, it is false that, and of course premise 1 also had this other thing. It had this either or, it is false that. So these are things in addition to the atomic statements. These are going to be the operators that were mentioned earlier, and I'll get back to those. But you can see both of these are compound because they both have parts which are themselves statements. The conclusion isn't compound. The conclusion is just an atomic statement. It does not have parts which are themselves statements. Well, notice that this entire argument really only uses two different atomic statements. Okay, the rabbit ran down the left trail, the rabbit ran down the right trail. Both of those show up here, sort of combined with this either or. One of them also shows up here, kind of with this it is false that in front of it. And one of them is just the conclusion itself. Okay? Now, compound statements are built up from atomic statements with statement operators. And we've already seen two of these, right? So the premise 1 built up the compound statement with two atomic statements and this either or. Okay, that's one of our statement operators. We also saw it is false that, which builds up a larger compound statement from an atomic statement. So here's, I've sort of in red put these statement operators so that you can see them. Now altogether in this course, we're going to have 4 statement operators that we're going to talk about. There's actually a 5th one in the optional material, but I'm not going to lecture on that 5th one. For students doing the optional material, look at the online materials for that. So there's 4 statement operators we're going to look at, sometimes called logical operators. Negation, which is expressed in a number of ways, and we'll talk about some of those, but it is false that, or sometimes you just put like an N''T on the verb, but these are different ways of negating a statement. Conjunction, which is usually expressed with and. There's some other words in English that express that. There's disjunction, which is usually expressed with or either or, and there's some other ways of expressing it also. And then conditional. If then, you can just use if, only if. There's a number of ways that English has to express the conditional operator. So just to see these in operation, here's 2 atomic statements. John is at the party, and there is pizza at the party. Those are 2 atomic statements. We can apply statement operators to those. So for instance, I could say John isn't at the party. And here we've got the first atomic statement, but I've sort of put the negation operator. I've applied the negation operator to that statement with an N''T on the verb. I could say there is pizza at the party and John is at the party. So I've used the conjunction operator to make a compound statement. Okay, so these are both compound statements. I could say either John is at the party or there's pizza at the party. Again, I've got a compound statement that I built up from atomic statements with a statement operator, the disjunction operator. Or I could say if there's pizza at the party, then John is at the party. Okay. Now, these are examples of statement operators working on an atomic statement to make a compound statement. But these operators have an interesting feature, which is what we'll call recursion. And what does that mean? That means that literally, sort of if you look at the Latin roots, it means to run again. Okay? Or another way of thinking of it is they can operate on something and then they can operate again on that product, right? And produce something, and then they can operate again on that product to produce something else, okay? What that means is that they can take as inputs, so to speak, they can work on not only atomic statements, but they can also work on compound statements to make even bigger compound statements. Now, most people are already familiar with recursion in the case of arithmetic. So what I want to do is take a minute or two to sort of remind everybody of what you already know, which is, I mean, many of you haven't thought about it in terms of recursion or have been introduced to the word recursion, but you understand the concept when it comes to arithmetic. So I want to remind you of that so that it'll be easier to apply it back to the case of statements. So, the 4 big arithmetic operators are addition, subtraction, multiplication, and division. And these are operators that can form compound arithmetic expressions from atomic arithmetic expressions. What's an atomic arithmetic expression? Just a numeral. Okay, so like 5 and 3 are numerals. But we can make compound arithmetic expressions like 5 plus 3, 5 times 3, by taking these operators that can then combine atomic expressions into a compound, a more complicated compound expression. Okay, and everyone's kind of familiar with that. But notice that arithmetic operators are recursive in that they can operate on expressions that are themselves the product of an arithmetic operator. So here's 5 plus 3. That's the product of atomic statements and the arithmetic operator of addition. But then we can take that expression, this compound statement, 5 plus 3, and use it as input to another operator. right? So here we have the arithmetic operator of addition combining two compound statements into a bigger compound arithmetic statement. And then this can obviously just go on forever, right? We can use addition again to combine two even bigger, compound expressions to a much larger one. And so we can make, arithmetic expressions that are arbitrarily complex because these operators are recursive. Okay. Now, the same thing is true in the case of statements and statement operators. Okay, so here's 4 atomic statements. You pay me the $20 you owe me. You come to the party. I'll jack your ride. I'll steal your wallet. So those are 4 atomic statements. And we can put those together with the statement operator. So for instance, I can take if-then, the conditional operator, and make a compound statement. If you come to the party, then I'll steal your wallet. Okay, but it's recursive, right? So we could make the even more complicated expression here. If you come to the party and you don't pay me the $20 you owe me, then either I'll steal your wallet or I'll jack your ride. Now what's going on here is I'm going to use sort of color to separate these out. This entire statement is a conditional. It's saying if something, then something else. Okay? But notice that these two parts aren't atomic. The thing following if, here it's atomic. If you come to the party, then I'll steal your wallet. So conditional can build a compound statement from atomic statements. But it can also build a bigger compound statement from smaller compound statements. Okay? I've got one here in light blue and then the other in yellow. Okay, but if we look at, let's just say, look at the light blue one, you come to the party and you don't pay me the $20 you owe me. That's compound. It's got these two components put together with and. Okay, the component that I've underlined in, I guess, violet or whatever that is, and I've underlined in yellow. But then notice that the component underlined in yellow is itself compound because it has the not there. So there's actually 3 levels of recursion going on here. Now I want to emphasize something, which is that this is not a matter, like what I'm talking about here, this recursion of these operators. The language might be new to you. Maybe you've not heard the word recursion before, and maybe you've not explicitly thought about this before. But this is stuff you do all the time. Everyone listening to this video and everyone in my logic class, even before you stepped foot in the logic class, you can understand sentences like this and you can produce sentences like this. So your brain can operate with recursive structures like these, okay? And you've been doing it all the time. You've been putting together atomic statements into compound statements with these operators, conditional, conjunction, all of this. So don't think of this as, oh, here's some new knowledge that you have to memorize, and this is stuff that's completely new to you, and you've never seen it before, you've never done it before. That's not what's happening here. What's happening here is that there's something that you've been able to do since you were 3 years old, but you've never really explicitly thought about it before, and maybe you've never, learned language to allow you to describe this thing that you've been doing since you were 3 years old. And that's what we're doing here now, is we're just making explicit something that's been implicit in your competence, in your abilities for a long, long time. Okay, so with this in mind, what are we going to do when we translate from spoken language or written language in natural language like English into formal notation? Well, there's going to be these parts that I'm going to talk about. First, we're going to talk about conjunction and negation explicitly, right? How do those show up in English, and how are we going to translate them into our notation? Then I'm going to talk about recursion. So we'll see recursive examples of those. That's probably where this video is going to end. Then in the next video, sort of finishing up chapter 1, we'll talk about disjunction and conditional, the second 2 operators. Sentences that use all 4 of these operators. Oh, there's a typo here. Disjunction, recursively, and then finally arguments. And arguments will be easy because that's just a set of statements. And if we can already do statements, all we need to get the argument is just do all of the statements and number them. Okay. So So let's start with conjunction. Here's two atomic statements. Roses are red, violets are blue. And I can put these together with the conjunction operator. Roses are red and violets are blue. Okay. You could also say both roses are red and violets are blue. So both and is another way of expressing it. Here's another way of expressing it. Roses are red, but violets are blue. So the word but is also operating as a conjunction here. Now, some of you aren't going to like that last part because you're going to think, well, but doesn't seem like it means the same thing as and. You're sort of right. So the reason is that logically, but is doing the same thing and is doing. It's telling you both of the parts are true. Okay, but has some additional meaning. It's not an additional logical meaning. It's sort of an additional, you can think of it as psychological meaning. It's also telling you that maybe the second one it's a little surprising that it's true given the truth of the first one or something like that. So it's got like there's some additional import to but that and doesn't have. But it logically, it also is saying the same thing that and does. It's telling you both things are true. Okay. Now, if we assign capital letters to these atomic statements, and we're going to do that, that's always the first step of finding the form of an argument, is finding the atomic statements and assigning a capital letter to each one. And you can assign any capital letter you want as long as they're different letters for different statements. It's usually good to try to find something that's kind of mnemonic for the statement. So I'm going to use R for roses are red and V for violets are blue. If we use these two letters, then I can translate this conjunction, and these are all the same conjunction. These are just different words English has for conjunction, as R dot V. So we're going to use the dot for our conjunction operator in this course. Footnote, different textbooks and different sort of courses or whatever will use sometimes different symbols. They'll use an ampersand, or they can use a sort of called a caret, kind of like a little upside down wedge. There's different symbols you could use for this. We're going to use a dot. The symbols don't really matter. If you've done logic before and this is not the symbol you're used to, don't sweat it. Okay, but we're going to use the dot. So all of these we would translate as R dot V. Now it's going to be convenient for us to have names for the components of a conjunction. And so we will just call those conjuncts. So in the conjunction R dot V, R and V, R is the first conjunct and V is the second conjunct. Okay. Next, negation. Now, conjunction was a two-place, what we will call a two-place operator, meaning it took two statements, and put them together into a compound statement. Those two things could be atomic or they could themselves be compound because it's recursive, but it takes two as input and produces one bigger. Negation is a one-place operator, meaning you have one statement. Now it could be atomic or it could be compound, but you have one statement and you're negating that statement to get your larger compound statement. Now there's a number of ways negation is expressed in English. So if we have this statement, the cat is on the mat, I could negate this in all kinds of ways. I could say the cat is not on the mat. The cat isn't on the mat. It is false that the cat is on the mat. These are different ways English has of doing what is the same thing logically, okay, negating that atomic statement, telling you that that atomic statement is false. Okay, if we assign the capital letter C to that atomic statement, then all of these negations we could translate as tilde C. So tilde is the symbol that we're going to use for negation in this course. Okay, so with conjunction and negation in hand, let's do some examples. Okay, so this is a very simple version of the kind of thing you're going to do on quiz 1 and also on the final. I'm going to give you a statement and say translate this statement into formal notation. So here's a statement: I am not thirsty. Step 1 is to identify the atomic statements involved. Now if I just give you an atomic statement and say translate it, that's easy. You just assign it a capital letter, and the capital letter is the translation. I'm usually not just going to give you atomic statements, though. Usually I'll give you compound statements, and this is a compound statement. But what's the atomic statement? Well, it's a compound statement, but it's got a negation in it, right? So the atomic statement is the non-negated version. I am thirsty. That's the atomic statement. Okay, and if we assign the letter T to I am thirsty, we can translate that as not T. So what I'm doing now is I'm rewriting the statement I gave you. I'm plugging T in for the atomic statement. What's left is the not. Okay, that's not here. So when I rewrite this but plug in T for that, I've got to leave the not here. So when I rewrite this, plugging it in, I get not T. Now the next stage is I'm going to translate the not into notation. And remember, not is just a negation. That's just tilde. So the translation of this into our formal notation is just not T. Tilde T. Next example. I am thirsty and I am hungry. What are the atomic statements? Let's let T be I am thirsty and H be I am hungry. Now I'm going to rewrite the original statement, but I'm going to plug those two things back in, and I get T and H. Now I'm going to do the final step. I'm going to sort of translate the logical operators, and I just get T dot H. Now let's do some recursion. I am not hungry, but I am thirsty. Okay, what are the atomic statements? Well, they're the same as last time. I am thirsty and I am hungry. Those are the two atomic statements involved. So now I'm going to rewrite the original statement, but I'm going to plug in T and H for the statements they stand for, and I'll get not H, but T. Remember, but is conjunction. Not is negation. So this is going to be a tilde. That's going to be a dot. Tilde H and T. Tilde H dot T. Okay, now there's a really important question to ask here, an important topic that's going to come up a lot, and it's going to come up more later, but now I want to introduce it now so you can start thinking about it now. And this is the topic of what we'll call the main operator. Now here we have two operators. There's a negation and then there's a conjunction. But in any compound statement, there's always going to be one that is the main operator. Okay? Well, what does that mean? The main operator is the operator that tells you what the form of the overall statement is. Is this whole statement, right, the one I asked you to translate, is that whole statement a conjunction or is it a negation? Okay, well, it's actually a conjunction. Okay, the first conjunct is not H and the second conjunct is T. But the whole statement is a conjunction. The whole statement is not a negation because the negation only applies to this part. It's not applying to the whole statement. It's only applying to the first conjunct is negated. Okay. I'm going to give you a slightly different example and you should be able to see what I mean. Let's look at this next example. It's not true that I am hungry and thirsty. What are the atomic statements here? They're the same two atomic statements. I am thirsty, I am hungry. Okay, let's rewrite the original statement. It's not true that H and T. Remember, it's not true that is just the negation operator. Now, the way to do this, and I'll talk about how we know this in a minute, you might think this is ambiguous, and this one actually is, but this one up here isn't. And I'll talk about that. That'll be the next thing. But what this is actually saying is it's not true that conjunction. So it's saying this conjunction is false. It is not true that H and T. So I put parentheses around this to mark off that this is a conjunction and this whole thing is negating that conjunction. This we would translate as tilde H and T. So I'm using parentheses to specify the structure of the components here. I'm going to talk more about that later. Hopefully that's pretty intuitively clear what I did there. Now the question is, how do you know, like why couldn't you do it like this, right? So notice here I said it's not true that, and I have h and t in parentheses. So I went from this to this. But you might say, hey Rick, couldn't you do it a different way? Instead of putting the parentheses here, couldn't we have said, it's not true that h and t, and then translate it this way? The answer is yes. If you just look at this one, then it's ambiguous. We don't know, if you just looked at this, whether this is where the parentheses go or whether they go around the h and t. But this is where going back to the original statement is helpful. Okay, so let's go back up here. It's not true that I am hungry and thirsty. If we try to put the parentheses around this, if we try to make and the main operator here, so we put parentheses around this first negation, it doesn't make sense now. Because what we're saying is the conjunction, the first conjunct is, it's not true that I am hungry, and the second conjunct is thirsty. Well, thirsty, that doesn't make sense. So that can't be the way that it works, right? So I'm putting little red X's through there. But if we do it the other way, right, let's just go back here. If we say, it's not true that, parenthesis, I am hungry and thirsty. That makes perfect sense, right? I am hungry and thirsty. That by itself is a perfectly legit statement. It's a compound statement, but it's a good statement. So that's how you can tell that it's not this. It's not this way. Because if you go back to the original statement and try to do it that way, it doesn't really work out. So let's compare the two that I've done. I'm not hungry, but I am thirsty. Here the main operator is the conjunction. Okay? The first conjunct is I am not hungry. The second conjunct is I am thirsty. But the conjunction is the main operator. It's telling us what the form of that whole statement is. It's a conjunction. With this one, the main operator is the negation. The negation is negating this conjunction. It's not true that, and then what's not true? Well, this conjunction isn't true. I am hungry and thirsty. Okay? So this one is a conjunction. The main operator is a conjunction. The first conjunct is not H. The second conjunct is T. This one is a negation. Okay? That's the main operator. The negated statement is a conjunction, but the statement overall is a negation. Okay, so that's it for this video. This was section 1.2 through 1.4. The next video, which will finish up, chapter 1, is going to go 1.2.5 to 1.2.8.